Hello everyone, and thank you for joining us today. Welcome to Megger's monthly webinar series. Today's topic is best practices for performing dielectric breakdown tests on insulating liquids. My name is Jamie Smith, and I'm the digital marketing specialist for Megger North America, and I'll be acting as the moderator for today's presentation. I will be supporting you on any technical issues or questions for our presenters and panelists as we go through the webinar today. Okay, and as you can see on the next slide, on the right of your screen, you'll see a control panel that looks similar to this one. You could submit questions at any time during the presentation by typing in the box highlighted in red, and I will read the questions out during the Q&A segment at the end of the webinar. All webinar attendees will receive 1 PDH or 0.1 CEU just for attending today. You will receive this in an email within 2 business days after the webinar. That email will also include a copy of the PowerPoint presentation and a link to the recorded video of the webinar if you'd like to watch it again or share it with your colleagues. Remember, you can ask questions at any time during the presentation, and they will be answered at the end of the webinar. Okay, today our presenter is Daniel Carreno, and he is an applications engineer for Megger. Also joining our presenter at the end of the webinar as part of the Q&A panelists are Volney Naranjo, our Megger Senior Applications Engineer, and Dinesh Shayir, Megger TSG Manager. Okay, let's go ahead and get started. Thank you for joining us today, Daniel.
Good morning, everyone. I would like to start by thanking you all for taking the time in your schedule to attend the webinar. We do hope that the information we are going to share with you today is useful. You can use it in your day-to-day activities. As Jamie already said, today we're going to talk about the best practices when performing dielectric breakdown tests on insulating liquids. But I'm going to start the presentation with a quick introduction on insulating liquids, why we use the oil, and more importantly, why it is important to test the insulating liquids in our electrical equipment. And in that regard, we're going to look at some of the applicable standards. We're going to go over the recommendations, and those recommendations will be covering the whole process, starting from the sampling itself and going all the way to when we are actually performing the measurement of a dielectric breakdown voltage test. So insulating oil, right? And we use insulating oil in electrical equipment for 2 very important reasons. The first one is the oil will serve as an insulating medium inside the equipment, right? As we know, the oil has excellent dielectric properties, and as we also know that the insulation system on a power transformer, for example, will consist of both solid and liquid components. And that brings me to the second important function of the oil inside the equipment, which is cooling. If we think again of that same example, a power transformer, the internal part of the unit has to be completely dry, or in other words, completely free of water content, as this will help to prevent partial discharge inside the unit, which if present will eventually cause electrical breakdown when the transformer is in service. Now this solid insulation is rated up to a certain operating temperature, and this operating temperature limit is basically defined during the design process of the transformer. If those operating temperature limits are not kept within the acceptable limits, then of course the insulating system in the transformer is going to start suffering degradation, and then it will eventually fail. Now, I've been mentioning power transformers, but that is not, of course, the only equipment on which we have oil as an insulating and cooling medium. As you can see, we can also have them in reactors, circuit breakers, cables, bushings, capacitors. a broad range of electrical equipment. Like I said before, the insulating oil is an excellent dielectric and an excellent cooling medium. Now, I would say whenever oil can be sampled from out of the equipment, then it is highly advisable to test it to make sure that the oil is in good condition to continue in service. Now, during the life of an electrical equipment, I will say we can highlight three very important moments on which we are going to test the oil. First of all, for acceptance testing, right? Either when we receive bulk oil shipments directly from the manufacturer, or for example, we go back to that example of that power transformer. For large units, usually the oil is shipped separately, either in drums or in tanks. And before we fill that unit with that oil received in separate containers, we need to make sure that that oil was handled properly and that it was not contaminated. Like I said before, that a transformer needs to be completely dry to avoid any degradation or early degradation of the insulating system. After that happens, after the unit will be in service for a certain period of time, for regular maintenance purposes, when we do our maintenance testing, very important to include oil test during those operations. Again, we need to make sure that oil is still in good condition, that it does not have any important contaminants, or it hasn't suffered any degradation that will affect the performance, the overall performance of the unit. When we do those maintenance testing, sometimes we find problems, right? Problems in the oil. And in certain circumstances, the oil can be reconditioned or processed to be used again. After those reconditioning processes have been finished, once again, we need to make sure that oil is suitable for operation, and then we have to test it again. So to summarize, three important moments to test the oil during the useful life of electrical equipment: acceptance during service for verification of in-service conditions, and after we do any processing or reconditioning of the oil. But what can cause that the oil being not suitable for in-service conditions? We all know the electrical equipment can suffer or can be in certain situations, not wanted situations, for example, arcing or overheating. We can also receive contamination from the ambient, external contamination like moisture or chemical contamination, or some phenomena inside the units can cause conducting particles to be liberated in the oil, and this will change the electrical, the chemical, and the physical properties of the oil, which again will cause premature deterioration of the insulating system. So that is the reason the IEEE C57.106, the Guide for Acceptance and Maintenance of Insulating Oil in Equipment, will give us guidelines to properly test the oil, right? It will tell us, it will list physical tests, chemical tests, and of course electrical tests. One of the electrical tests is, of course, dielectric breakdown voltage measurements. That's what we're gonna focus on today. And just as a reference, I wanted to show us what other type of common oil tests are performed. In the electrical part, you have dissipation factor, for example, resistivity. In the chemical, a very, very known, very commonly used the DGA or dissolved gas analysis to verify the gas or the dissolved gas content in the oil, the moisture or water content. On the physical section, we have color, interfacial tension, specific gravity. And like I said, this is not a full list. The IEEE standard that I just mentioned will include a full list of recommended tests for the three categories: electrical, chemical, and physical. Again, focusing on dielectric breakdown voltage. We're going to look mainly into ASTM standards for the actual testing itself, right? The standards published by the American Society for Testing and Materials. And all these standards fall under the D27 committee, right? The electrical insulating liquids and gases, and all described in the volume 10.03. Both the IEEE standard that I mentioned before, IEEE 57.106, and standard ASTM D3487 will give us guidelines in regards to the actual limits or the minimum breakdown voltages we need to verify depending on the application we are taking our samples from. Continuing with ASTM, as you can see, I have ASTM D923 highlighted in red, the standard practices for sampling electrical insulating liquids. I wanted to highlight this because you will see as we go through the presentation that the best practices will start even when we are just out taking the samples to test. It's of paramount importance that we follow all the recommendations listed in the standard to achieve accurate results, and so we can have a valid analysis of the oil we are testing. For the actual measurements of dielectric breakdown voltage, we're going to look into ASTM D877 and ASTM D1816. Both of those will give us step-by-step procedures to actually make the measurements, and like I mentioned before, they will give us guidelines and recommendations to achieve accurate and good valid readings. Now, none of the standards I've been mentioning focus on safety, right? And you will find those notes in the standards themselves, but they will also give us the most important guidelines, which I try to mention here. Of course, initially, extreme precaution and the proper protection of, the personal protection equipment should be used, especially when taking samples from energized equipment. Second of all, we need to make sure that the unit or the equipment we are taking samples from has positive pressure, right? If the equipment does not have a pressure vacuum indicator and we cannot confirm that that it has positive pressure inside, then we cannot take a sample out of that unit. Also, prior taking those samples, make sure you know and understand the PCV content if present of the oil you are sampling. As a mandatory conditions as well, make sure that you check the level of liquid, of insulating liquid in the equipment you are taking the sample from. Make sure, of course, that the level is above the minimum indication. And of course, if that level is right at the limit or worse below that limit, you should not draw any oil out of that unit. As well as completely not recommended drawing samples out of energized instrument transformers and energized switches or cable termination compartments in network transformers. Now, going into the sampling, again, like I said at the beginning, I want to focus on this part. Is really, really important. And first of all, we need to make sure that we have the proper ambient conditions to be able to sample the oil from our equipment. First factor we need to look at is the relative humidity in the air. If the relative humidity exceeds 50%, then it's not advisable to take the samples, because I mean, we of course can take the samples, but if the relative humidity is above that threshold, 50%, there's a high risk that we're going to get our samples contaminated with moisture from the air in the ambient. When we do take samples, make sure you seal and label the container right after you finish filling those. Again, make sure that you are not getting external contamination in the oil you are sampling. Now, for dielectric breakdown voltage testing, the minimum volume you need is about 0.6 liters or one quarter of pints. But again, this is the minimum volume needed. I would recommend to take at least 2 or 3 times this quantity, and that is because commonly you either have to repeat your measurements, and also take into consideration that you're going to use the same oil from your sample to rinse and the vessel you are using to test. So again, you need some extra oil for those activities, and also need enough oil in case you need to repeat the measurements. Now, when we are out in the field, we all that been out there in the field, we know that not every equipment will have a convenient sample valve or very easy to install adapters so we can sample the oil. So we need to be ready with a sample toolbox, with tools, with wrenches, fittings, Teflon tape, sealants to reinstall the caps in the valves. And also, of course, even when nobody wants a spill of oil, those are not uncommon, right? So make sure you are ready for a spill, have more than enough absorbent pads and cleaning materials, because like I said, even when nobody likes and nobody wants an oil spill, those are not uncommon. So be ready to clean with the proper material. As I mentioned before, the sampling process is of paramount importance to achieve accurate results when we are taking our measurements. So another factor we need to look at is the bottle or the container we are using to store our samples. If we look again at the standard D923, we will find a table that will list different types of containers recommended, and it actually will give us advantages and disadvantages depending on the type of measurement we want to do with that sample we are taking. As you can see here in the slide, I have a glass syringe, for example. It can be used for dielectric breakdown testing, even though it's most commonly used for DGA. A welded seam metal can, as well as a seamless aluminum can also be used for dielectric breakdown testing, with the factor that you need to fill those to overflow, and that is to avoid moisture getting inside the sample. Now, as you can see, the containers based on high density polyethylene are crossed out, and that is because that material can be permeable, which means that it can allow moisture inside the sample, which will affect dielectric breakdown voltage reading. So preferable to use glass or metal cans for dielectric breakdown voltage testing. For the sampling valves, I will say if you are using a rubber hose adapter or any type of oil-resistant plastic, make sure you don't reuse those. Let's say you're out in the field, you're going to sample oil from 5 different transformers, from 5 different circuit breakers. So again, if you're using any type of adapter or oil resistant tubing, plastic tubing, any type of plastic or rubber, make sure you don't reuse them. So make sure you have a new set for every unit you are going to sample oil from. Now, going into the actual process of taking a sample, I want to go step by step so we all can review and we're on the same page, again, when taking an actual sample. So first of all, make sure you have a big enough container for flushing oil, I'm sorry. So of course, place that below your sampling valve and proceed to remove the cap from the sampling valve. After you remove the cap, be ready with lint-free, either lint-free paper or lint-free clothes to clean that area you just exposed, right? The internal thread of the valve. Make sure it's free of contaminant, of solid contaminant. Make sure you remove all the sealant residue that might be in there, any moisture. Make sure it's clean, and again, use a lint-free cloth. When you finish that initial cleaning, then you can proceed to flush at least 2 liters, preferably 4 liters of oil. And again, this is to ensure that there is no external contaminant in this area, so that the oil we are taking in our sample is a close or a representation of what we have inside that equipment. When you finish that initial flushing, then close the sampling valve, and you can go ahead and install your adapter. As well as, in this case, we're using a plastic or an oil-resistant plastic tubing. And remember, this being plastic has to be new for every equipment you are sampling oil from. So proceed to install the adapter and the plastic tubing. And now again, we are sampling for dielectric breakdown voltage. So in this case, we're using an aluminum container. Now, I would say if you are using either metal, like this aluminum bottle, or glass, that initial filling will be partial. Make sure you do a partial initial filling, and then use that partial filling to swirl that oil inside the container, so that oil it gets in contact with all the internal wall of the container. And that is done to prevent any possible condensation because of the difference in temperatures from the oil in the equipment and the container itself. So those initial flushes, or I would say make 2 or 3 at least flushes before actually filling your container. And again, you need to do this when either you're using a glass container or a metal container. Okay, after you finish those initial flushings, you can proceed to do the filling of your container. And to do that, we have 2 options. You either put the end of the tubing all the way in the bottom of the container, so the oil will fill the container from the bottom up, or place that end of the tubing close to the internal wall of the container, so the oil will travel along the wall to the bottom of the container. And we need to do this to prevent any insertion of air or air bubbles in our sample, which will also can have the possibility of affecting our results when we are performing the measurements. Again, as I mentioned before, this is a metal container, so we need to fill it to overflow and then proceed to seal it and label it for later testing. If you are using a glass container, then you need to leave some space inside the container to allow the liquid to expand in case of any change in temperature. I will also say the flow of oil should be gentle and constant from when you start to those initial flushings of the container until you finish the last filling of your last container, in case you're filling several containers. Again, the flow should be gentle and constant. By that I mean you should not interrupt the flow of oil between the flushes or between different containers. Okay? So after you finish filling up your last container, you have all them sealed, proceed to remove the tubing. Of course, close both of the valves in your adapter from the sampling valve. Then proceed to remove the adapter and make sure you leave everything clean. Again, this will facilitate future samplings. So that would be the actual process of taking an oil sample, and all the recommendations we just discussed are ensuring that you are getting, like I said before, a true representation of what is of the oil inside the equipment you are sampling the oil from. So now we already discussed getting our samples for testing, right? So going into the testing itself, the dielectric breakdown voltage of an insulated liquid would be a measure of the liquid's ability to withstand electric stress without failure, right? So when we get these measurements, we will get an indication of the presence of conducting particles in the liquids or contaminating agents such as water, cellulose fibers, dirt, or any type of contaminant, like I said before, that will diminish the dielectric properties of the oil and which will cause an eventual failure in our electrical equipment. Like I already mentioned, we're going to look at two different standards, ASTM D1816 and ASTM D877. The actual procedure on both standards is pretty similar, and the factors defining each one of the methods also have some similarities, but also some important differences. This is a comparative table of both of the methods. So let's see what are the most important or the key differences between the two. The first evident, as you can see in the table, although the most evident difference will be the shape of the electrodes. For ASTM D877, the electrodes are round disc, flat disc with these sharp edges, as you can see in the picture I'm pointing. And when you install the electrodes in the actual vessel, you will install them in a way that these faces are completely, those internal faces are completely parallel to each other, and both of the electrodes should be horizontally aligned in the axis. The gap or the space between the two electrodes will be 2.54, and again this is for ASTM D877. As you can imagine, when using this method, there is a substantial stress concentration at the sharp edges of the flat disc faces. On the other side, for ASTM D1816, as you can see in the picture, the electrodes will be mushroom type, or otherwise called BDE type electrodes. The gap is also different. For this method, we have two options, either 1 millimeter or 2 millimeters. Now, these electrodes are actually a closer representation of, for example, electrodes that you can find in a transformer. If you look at any internal part of a transformer, it's difficult to find sharp edges in the connections or the cable routings or the conductors inside the transformer. So again, this is a closer representation of what you can find inside of a transformer. And that is the reason on IEEE, the recommended standard for transformer testing is method described in ASTM D1816. D877 is recommended for new unprocessed oil received directly from a supplier or service aged oil in circuit breakers. I will also say that when using ASTM D877, the sensitivity to contaminants and moisture decreases when the test voltage is above 25 kilovolts. Another important difference is for ASTM D1816, we use an impeller. As for ASTM D877, there is no stirring of the oil during the test. Another difference is the rise rate for the test voltage. For ASTM D1816, so much lower, 0.5 kilovolts or 500 volts per second versus 3,000 volts per second for ASTM D877. Other than that, the method itself, both of the methods are pretty similar. The number of breakdown voltage measurements is the same, even though ASTM D87 allows for a second round of measurements in certain conditions. I will go over that in a minute. But like I said, other than that, the conditions are pretty similar to each other between the two standards. So now let's look at the actual test vessel we need to perform dielectric breakdown voltage test. It is recommended that the material of the vessel is, you can see through the walls of the vessel, so you can observe the breakdown. And in the case for ASTM D1816, the vessel cover should have provisions to assemble the impeller that is needed for performing or during performing the actual measurements. That impeller will rotate at a speed between 200 to 300 revolutions per minute, and that impeller should rotate in a way that it will cause a downward direction flow of the oil during testing. Now, when you are preparing for the test, you need to make sure that vessel you are about to use is completely clean. It is recommended that you clean that test vessel with either lint-free paper or lint-free clothes. Then you can proceed to adjust the gap between the electrodes. Well, just coming back to the cleaning, you can use a dry hydrocarbon solvent like kerosene or toluene, for example. And after you finish the internal cleaning of the vessel and the electrodes, make sure you don't touch the inside part of the vessel or the actual electrodes with your bare hands. If you do it, then you're going to leave a greasy residue or moisture, and again, contaminating your sample when you fill the vessel. Also, as a recommendation, if you are not going to use your unit, your dielectric breakdown voltage testing unit, make sure you don't leave those vessels empty for long periods of time. Because if you're going to have them stored, just make sure you fill those vessels with oil, with the same oil you use to test, so you prevent any contamination of the actual vessel. Also, the electrodes should be in good condition. If you see any etching, scratching, or you see the electrodes have carbon accumulation because of the actual measurement, remove them and have them polished, or just get a new pair of electrodes, right? The electrodes should be in excellent condition to get accurate results. If you do polish the electrodes or get a new pair, it's just advisable to immerse them in oil prior that initial use after the polishing or when you get a new pair. Now for the sampling, we already discussed sampling in detail, but again, just to summarize, you need to review ASTM D923. On that standard, you will find the procedure we just reviewed, as well as recommendations to both sample from different type of containers when you get oil directly from a supplier, and also details on the containers recommended for each type of test in the oil. Make sure you seal and label your samples for future testing, and when you are just preparing, right before the actual performing of the test, make sure you inspect the presence of any visible particles or any foreign matter in your sample. After you do that, let's say you brought your equipment from other location as well as your sample. So before the beginning of the actual test, make sure you allow enough time for both the sample and the vessel to reach ambient temperature or room temperature between 20 to 30 degrees C. Then when you are ready to fill that vessel with your oil, gently invert and swirl the container of your sample to create an homogeneous sample before filling the vessel. Then, just like when we did with the actual sampling, make a partial filling of the vessel and use that oil to swirl and sort of rinse the internal part of the vessel. And again, do this 2 or 3 times. Then you can proceed within 30 seconds of the last rinsing to slowly fill the vessel with oil. And again, that slowly filling is to avoid any air bubbles when you are filling the vessel. Fill the vessel up to the level indicated in the vessel itself, and then proceed to place the cover or the baffle in a way that no air is in contact with the actual oil. Okay. Of course, this part of the procedure applies for both D1816 and D877. And from here, I would say most of the equipment in the market will continue to do the test automatically, right? For ASTM D1816, we have a 3-minute waiting period between when we just finish the first filling to the first application of voltage. And again, most units will do this automatically. We'll wait for 3 minutes before applying that initial voltage. And then the initial voltage application will start for D1816 at a rate from 0 up to the breakdown voltage using the 0.5 kilovolts per second rate. After that initial breakdown, we have a waiting period again between 60 to 90 seconds. So minimum 60 seconds, no more than 90 seconds before the next application of voltage. And we need 5 total measurements for D1816. After the last measurement is done, the unit will give you, your instrument will give you a mean calculated value, a range, the standard deviation, using those 5 measurements just taken. Again, this is for ASTM D1816. For ASTM D877, of course, we need different electrodes. The gap is 2.54. For procedure A and ASTM D877, we're also going to do 5 breakdown measurements. The waiting interval between measurements between breakdowns is 1 minute. Okay, you can see it's pretty similar to D1816. ASTM D877 has the second procedure called procedure B. The difference between procedure A and procedure B will be that each one of those 5 breakdown measurements will be done with a different filling. So I will do my first filling, take one measurement, then discard that oil, fill the cell again, do the second measurement, and so on. So I need 5 measurements with 5 successive fillings of the oil I'm testing. And this, again, will give us the range, the mean value, the standard deviation of those 5 breakdown voltage measurements we just took. So why do we need those calculated values? There is a factor called test acceptance criteria used for both methods. For ASTM D1816, we have 2 criteria depending on what gap setting we had in our electrodes. Right, I said the unit will calculate a range. So what is the range? The range is just the difference between the maximum voltage breakdown voltage measured and the minimum breakdown voltage measured. That range should be less than 120% of the mean value of those 5 breakdown voltages measured. If you're using 2 millimeters, then that range should be less than 92% of the mean value of the 5 breakdown voltages. For ASTM D877, pretty similar criteria. When we do 5 breakdowns, the range, remember, the difference between the maximum and the minimum recordings should be less than 92% of the mean value of the 5 breakdown voltages. Now, here ASTM differs a little bit from D1816. If this first validation fails, then the standard allows to do another 5 measurements, so we will have a total of 10, and using those 10 values, we'll calculate the mean, we calculate the range, and that range should be less than 151% of the mean value, remember, using the 10 breakdown voltages values. Now, we're talking about test acceptance criteria, so what does it mean? This acceptance criteria for both D1816 and D877 is just to validate our testing, just to validate our method. When we get acceptable ranges, take for example this on ASTM D877, when it's less than 92% of the mean value, usually our unit will give us a pass, test status pass. That means our measurement, our method is valid. We are not assessing the quality of the oil yet. It's just to validate that our measurements are valid and we can use those measurements to now assess the quality of the oil. And on that part, we're going to look again to ASTM D3487 as well as IEEE 67.106. In the ASTM standard, we will have limits for received new oil and new processed oil. So remember, ASTM D877 is only going to give us a recommendation for received new oil. And for ASTM D1816, we have values for both of the settings depending on the gap we are using. We look at the IEEE recommendations in terms of those minimum values recommended for dielectric breakdown voltage testing. We will have different categories depending on if the oil is new, as received in new equipment, or if it's in service or service age oil. And also different values depending on the rated voltage, the nominal rated voltage of the equipment we took that sample from. So we will have a setting for less than 69 kV, between 69 to 230 kV, between 230 kV up to 345 kV, and 345 kV and above. And again, limits for 1 millimeter gap and limits for 2 millimeter gap. Same standard, IEEE 57.106 will also give us limits for oil used in low tap changers and circuit breakers. So notice that the only recommendation that these standards give us using D877 is for continued use of service age circuit breakers insulating oil. So I want to summarize everything we just discussed, right? With things easy to remember do's and don'ts list of when we are performing dielectric breakdown voltage testing. For the do's, of course, use the proper procedure recommended by the standards depending on your application. Right? Be mindful, like I've been saying this, I don't know how many times during the presentation, I cannot stress it enough. Be mindful of cleanliness as well as the ambient conditions when sampling. Use the right type of container depending on the measurements you want to do in your samples. Follow the recommendations to prepare the vessel every time you start a test. Use only the recommended solvents when washing the vessel when necessary. Use the oils from the same sample you are testing to rinse the vessel prior performing the test. And of course, follow the local regulations, your local regulations to discard the tested oil. On the don'ts, don't use clothes or cleaning materials that may leave lint or residues that will contaminate the sample. Do not reuse a sample unless indicated by the standard. By that, I mean don't test a sample twice unless the standard calls for that. Do not reuse any type of oil-resistant tubing or adapter. Use it to sample, like we covered that in the sample part. If you are sampling oil from different equipment and you are using plastic adapters or plastic tubing, have one new for each equipment you are sampling oil from. Do not leave your test vessel or vessels empty for long periods of time. If you need to store them, make sure you have them filled with oil. Do not use scratch or damage or electrodes with carbon residue. Make sure you have good condition electrodes on performing your test. And do not use uncalibrated or out of calibration equipment. I want to use my final 2 or 3 minutes just to quickly go over the Megger offering for dielectric breakdown testing, right? The family of OTS instruments, and we have 2 different lines. Laboratory instruments ranging from 60 kV, 80 kV, and 100 kV, and on the portable part, going from 60 to 80 kV. Of course, the portable instruments can operate either connected to the mains or using an integrated battery. In terms of the features, we talked about that sequence, right? Depending on what standard we are using, well, the family of OTS units will have the integrated sequences, so we'll do that automatic part as we discussed. You have all your readings, the mean value, the range, and it will tell you if that method was valid or not. And of course, this applies for both the last and the portable lines of instruments. On the vessel part, clear material as we discussed, easy way to change or interchange the electrodes depending on the type of test we are performing, accurate and smooth gap gauges. These are made out of anodized aluminum, and an easy mechanism to adjust the gap, and really important, lock it in place when we finalize adjusting that distance between the electrodes. We said when we are using ASTM D1816, we need a cover that has the means to assemble an impeller. So the family of OTS units is, has the cover that will allow an impeller to be mounted and used when using ASTM D1816, and also the cover will have a buffer plate that will prevent any moisture or any air to be in contact with the oil. Also, the vessel really easy to pour, right, through successive fillings or when testing different samples, and really easy to clean. And like we said, even though we don't like spills, they're not uncommon. So the unit has an easy accidental spill oil removal system with an exit in the back of the unit. And the vessel bay where you mount the vessel to perform the test is really easy to clean. Now with that, I finished my presentation, but don't sign out just yet. Jamie has a couple of important announcements to make, and then we can go to the Q&A session.
All right, thank you very much, Daniel. At this time, the webinar is officially concluded. Before we begin the question and answer session, I'd like to share with you an upcoming feature article by Megger Cable Applications Engineer Jason Sushak that will be released later this month. The title of the article is Improving System Reliability with Offline PD Testing. And you can subscribe to the NETA World Journal for free just by visiting their website. So we recommend that you do that just so you don't miss this article and other great informational content in the future. Okay, now we're going to take 30 minutes to answer as many questions as possible. If you have any other questions, please submit them now into the Q&A box. For those that are leaving, when you close the webinar window, a survey should pop up on the screen. We would greatly appreciate it if you could just take a couple minutes to provide your feedback so we can continue to improve future webinars. Also, a copy of the presentation will be emailed to everyone within the next couple business days, as well as a recording of the webinar. And then also a recording of the webinar will be available on our website at megger.com/webinars in the next week as well. And you can also view previous webinars there too. Our webinar page also contains the schedule for all upcoming webinars as well. All right, now let's get to some of your questions. The first question we have is, who is responsible for the chemical test? The electrical technician or a chemic?
Good morning, everyone. This is Dinesh. That's a good question. There are a number of electrical tests and chemical tests that are recommended. And usually when you talk about acidity or the color or those kind of tests, what happens typically is that whenever you take your oil sample and send it to lab for DGA analysis, that's the time that they do all these chemical tests. So usually what we have seen in the field is that tests like dielectric breakdown or power factor, those are typically done by technicians. But when you talk about the other tests, the more of like chemical nature tests, acidity, the color, and then there are a couple of more listed in the IEEE standard. Those are typically done by lab when you send the DGA sample for your analysis.
Okay, thank you, Dinesh. Next question. It seems you showed some capacitor cans that were part of a capacitor bank. You're not supposed to take oil from any capacitor cans, correct? Yes, Jamie or the audience, at the beginning of the presentation, we showed some equipment, electrical equipment that hold oil for as insulation medium. And in these equipment, there's really no means for sampling in some of them. Some of them are very small and don't have means of sampling, or you are not supposed to take oil out of them because it will be reducing the volume of the oil drastically. So they were shown there just for purposes of illustrating where the oil is used. And as a rule, basically, if you want to sample oil, you look for equipment that is has the means to sample the oil, and if by any means you need to take a sample on a piece of equipment that doesn't have a means to sample, like appropriate means to sample, well, that oil needs to be replaced because you will be reducing the volume drastically. So the purpose is to never reduce the oil volume drastically. Okay, thank you, Volney. Next question. He keeps talking about oil or insulating fluids. Is he referring to mineral oil? Second part of that question is, are there any testing standards that cover silicone fluid or the new less flammable fluids like biotin? So the focus of the presentation was about sampling of insulating liquids, and that's the title of the standard. So yes, this standard applies for any type of insulating liquid like the natural esters or biotemp, silicone, all of those new insulating mediums, liquid insulating mediums. The sampling procedure is the same. You try to take the most care when sampling to avoid contaminating the sample. And there are other standards for specific insulating mediums. There's the standard for silicone, but basically they list the same electrical tests as for the oil. So there are some slight variations, and even in 877 or 1816, there's some indications for that type of insulating medium that you probably spend a little bit of more of time in between tests, or you do longer pauses to perform the test just because they have a different characteristic. But the standards are mainly the same, and now we are starting to see specific standards for these elements or these insulation, but not drastic changes in the electrical testing. Okay. Thank you, Volney. Next question is for Dinesh. Is there a standard method recommended for polishing electrodes?
That's a very good question. I would say, reason being that a lot of times we don't realize that if there are scratches or any kind of carbon accumulation on the electrodes, that can drastically change your dielectric breakdown voltages. So that's a good question. I guess I would say every 6 months to a year, I would check for my electrodes if there is any kind of scratches that gets developed over the time. So ASTM standard D1816 does talk about how to polish the electrodes. The section is section 7.4, and I'm going to just read that so that way users who may not have access to the standard, they can kind of get that information. So it says that section 7.4, polishing of electrodes, when electrode shows slight edging, scratching, pitting, or carbon accumulation, they should be removed from the test cup and polished by buffing with jeweler's rouge using a soft cloth or soft buffing wheel. The residue from the buffing should be removed by repeated wiping with lint-free tissue paper saturated with a suitable solvent. This should be followed by rinsing the electrodes with the solvent and, if possible, ultrasonic cleaning. After careful inspection, any electrodes from which pitting cannot be removed by light buffing should be discarded, as more refinishing would destroy the electrode contour and dimensions. So you do not want to over buff it, but at the same time you should do the slight buffing to take all the rough edges or scratches or pitting out of the electrode surface. So again, it's ASTM D1816 section 7.4 that talks about polishing of electrodes, and you should do it every 6 months to a year time frame.
Thank you, Dinesh. All right, next question for Daniel. What standard do we use to test new and old oil? Second part of the question is, under what conditions shall one decide whether the BDV test is done per D877 or D1816?
Okay, we chose these two questions together because the first one is actually part of the answer of the second question. Like the differences between when we use D877 and D1816 depends on both if that oil we are testing is just received from the supplier, new oil, or if it's service aged oil. The second criteria will be the application, right? If we look at IEEE P59.106, it will tell us that from other than new oil, we also can use D877 for oil taken or sampled from low tap changers and circuit breakers. And D1816 for transformer applications and for service age oil. Now, this has to do with the shape, mainly with the shape of electrodes. Remember that D1816 use this mushroom type, this round electrodes that will closely represent, it's a closer representation, I should say, of what you find inside a power transformer. Also, D877 will be less sensitive to water and conductive contaminants, especially when testing above 25 kV.
Okay, thank you, Daniel. And the next question, it seems like this vessel is a portable device. Will this device be able to provide us the PF at 25C and 100C? How about the acid number and moisture level? Or is it only breakdown?
Okay, so the first parts of the question, yes, it's a portable vessel or something. Actually, the instrument is a portable device. It's meant for field testing. And the vessel is something that you can take out pretty easy from the unit to pour the oil and prepare the testing. Now, this is only for dielectric breakdown. So this test and these standards that we covered today in the webinar, it's only for dielectric breakdown. There's a different standard for power factor at 25 and 100 degrees, and if I'm not wrong, that's 924, ASTM D924, and that one specifies a different test, and the instrument has to be totally different. The vessel is actually a cell, an electrode, where you can apply voltage up to 2 kilovolts to perform the test, and then that same cell or vessel is the one that is heated up to 100 degrees, and then you perform the power factor test again. So it's totally different instruments, totally different standards. And the acidity level, no, that's a chemical test that it's performed at the lab when you submit a sample to the test lab.
Okay, thank you, Volney. Next question is for Daniel. It's recommended to do oil tests at temperatures, or is it recommended to do oil tests at temperatures above 30 degrees Celsius?
Well, very short answer is no. The standard will call for to do the test between 30 to 30 degrees C. 20 to 30, yes.
Thank you, Daniel.
Just one more addition in that question. If you were to take an oil sample, let's say the transformer was energized and you just took the oil sample and the transformer oil gauge tells you that the temperature is 45 or 50 degrees C, then you may get a different number, but there are just so many different variations or different factors that can affect your oil dielectric breakdown that it is always recommended to eliminate the temperature variable. So it is recommended in the ASTM standard to always perform the test between 20 to 30 degrees C oil temperature.
Okay, thank you. Next question. Is there a correlation between breakdown voltage and the amount of water in oil?
Okay, that's again a good question to ask, because again there are different tests that are recommended. There is a ppm test or water in oil test, which is done by Carl Fisher technique. You do DGA, and then you also do this dielectric breakdown. So each test has its own importance. When you perform dielectric breakdown, you cannot directly correlate that with the amount of water present in that, because the dielectric breakdown depends upon not only just the water content or moisture content, it also depends upon any kind of carbon contamination, any kind of other impurity in the oil. So dielectric breakdown is just telling you what is the dielectric strength of the oil, and the strength of the oil can get affected by a number of different factors, and moisture or water is just one of that. So it does affect, but there is no direct correlation.
All right. Thank you for that answer, Dinesh. All right, next question. Is there a way to compensate for high humidity samples? Second part of the question, we work in an area that has a very high humidity most of the year.
Well, basically when you perform a dielectric breakdown, you're testing for moisture content, or just to determine if there's any moisture content or if there's any contamination in the oil. So really there's no compensation, and what you do with the sampling, with all of these careful procedure to sample the oil, is to reduce the effect of or any chance of contaminating the sample with external moisture or external particles or elements that can affect the result of the oil. So short answer, there's no compensation factors for humidity, and basically that's what you are trying to do with the sampling, avoiding the contamination of the oil with the external factors.
Okay. Thank you, Volney. Next question. We moved from an ASTM D877 to a D1816 a few years ago. Are the results from two different test standards comparable, and which test is preferred?
I know this answer doesn't sound right, but the correct answer is it depends. So I will elaborate more on this one. The two tests as per ASTM 877 or D1816 have their own place. A lot of utilities have been doing ASTM D877 test, and because of that, because of all the history or the historical data that they have, even though ASTM D1816 test is more preferred method for insulating liquid in transformers, a lot of time utilities may not switch to ASTM D1816 because they have some history with the D877 test. So again, as I said, it depends upon what the practice is. You will get slightly different numbers between the ASTM D877 and D1816 test, Reason being the rate of rise of voltage, the electrodes that you use, the gap between the electrodes. So the test setup is quite different, and that's the reason why you will get different numbers. Now, if you want to move from one method to the other, you just have to make sure that your oil is in good condition. And then if you want to switch to the other one, knowing that it is in good condition, you move to a different standard, which is D1816, and you stick with that moving forward. But you will get differences between the two standards. So it depends from one utility to the other as what they would like to do.
All right, thank you, Dinesh. Next question, is BDV criteria enough to decide on corrective action? And also, do we also need to take into account moisture content, degrees of wetness, acid number, power factor, and IFT?
Okay. Again, as we say in the electrical testing world, that one single test cannot give you all the information that you're looking for. Dielectric breakdown test is only one parameter in finding the condition of the insulating oil that you have in your asset. So I would certainly do DGA. I would certainly look at the ppm content inside the oil, and I would look at all those tests and then come to a kind of decision if I need to do something about it. Another very common test that people do is the power factor test on the oil at 25 degrees C and 100 degrees C. So each test has its own place. I will not solely make my decision purely based upon the dielectric breakdown test. That's just one of the tests that I need to do. Just to reiterate, DGA, power factor test, dielectric breakdown, ppm levels, those are very common tests that I would perform on the oil.
Okay, thank you, Dinesh. Next question, what is recommended frequency and options for calibration of a OTS 60 PB unit?
Well, there are two parts in calibration, right? The first one will be verification, and the second will be adjustment of the calibration values. For the first part, the verification, you can do the part to check the volt to ensure that the voltage that the instrument is showing that it's applying is the actual voltage in the output, or the voltage applied to the electrodes in the vessel. Like I said, you can do that in the field by the means of a voltage checker accessory, and yeah, I would recommend to do that at least once a year or twice a year. And like I said, that can be done in the field. And if the calibration needs to be adjusted, well, that needs to be done in a calibration center. And that recommendation for that is to do it once a year.
All right, thank you. Next question, can we apply standard D877 or D1816 when testing current transformer oil?
Yes, those standards are for insulating liquids. So basically any oil or any liquid that you are using for insulation in any electrical equipment, you can use these standards to perform the breakdown test. So the answer is yes on that one.
Thank you. Next question, what can you use to clean the inside of the sample valve if it's dirty?
Well, that's, I think, a good question too. Like I mentioned before, we don't want to contaminate the sample of oil we are taking. Right? So the only option we have, like I said, is the use of lint-free clothes or lint-free paper. And if some sort of liquid is necessary to clean the inside of the valve, the only option you have is flushing the oils. That is the reason that 2 to recommended 4 or preferably 4 liters of oil flushing is recommended to clean, to take out any existing contaminant inside the valve. Like I said, you don't want to contaminate your sample, so the only option you have is flushing oil and the use of lint-free paper or clothes.
Thank you, Dana. Next question. Also, is it not recommended to use plastic bottles? Is this because it can expand? And second part of that question is, I've seen oil test bottles with either clear or plastic or opaque bottles. Why are these acceptable?
Remember in the standard, right, the D923, shows that some type of plastic bottles will be permeable. The problem is not that it can expand, but they will allow moisture because they are permeable. But again, there's only certain type of plastic containers.
Thank you, Daniel. Next question. Since the sample is usually taken from the bottom part of the tank, can we be sure the sample we are taking represents the actual condition of the oil?
Well, the oil inside the transformer, inside the tank, is permanently moving. It's always recirculating due to natural effects or because it is forced. So it's always going to be not settled, and it's going to be different. So it's always going to be mixed. And the other reason it is accurate or it's good is because in the sampling procedure, you flush a little bit of oil before taking the sample, so you are sure that you circulate a little, some oil there, and whatever is close to the valve and it's allocated there, it's flushed before taking the sample.
Thank you, Moni. Next question, will the DGA test be sufficient enough over the dielectric breakdown voltage test?
I guess this is continuation of one of the previous question. Can I just do one test and not worry about the other? Our response, based upon the experience that we have, that each test has its own place. We have heard this many times, that taking a oil sample and doing DGA on it is basically taking a blood sample and like having doctor do the different tests on the blood sample. So when you do the DGA test, you look at different gassing, different ratios, any kind of arcing taking place inside the transformer oil, those kind of things. But when you talk about dielectric breakdown, you are basically looking at what point the dielectric strength of the oil would give up. So if I would have to kind of give you an analogy, think of this one as that taking a blood sample and running a test is one part of it. And then the other thing is that if I ask a person to run, and then after what time that they would give up, in other words, they're exhausted, they feel tired, and they cannot move any further. So the two tests are different tests, and they give really important information, but I cannot substitute one over the other. So that would be the response.
Thank you, Dinesh. Okay, next question. When do you use a Megger OTS and Megger OTD?
Okay, today we discussed dielectric breakdown voltage testing, right? And the Megger OTS, the Megger oil test system, will help you to perform those measurements. The Megger OTD is also for oil testing, but if you remember from the very first few slides when I discussed electrical testing on oil, the dissipation factor and resistivity is also called on the standard. And the Megger OTD, the Megger oil tan delta, will help you to do both power factor and resistivity measurements in oil.
Okay. Next question, will the breakdown cause any scratches on the polished electrodes?
No, well, no, not scratches, but like I said, like Dinesh previously said, it is recommended to check your electrodes at least once or twice a year. The testing itself can cause carbon deposits in the electrode, not scratching, but carbon deposits in the electrode, which will greatly affect the results.
Okay. Thanks, Emilio. Next question. If the SV is in the unacceptable range, will the instrument automatically reject the result?
Both ASTM D1816 and D877, they ask to calculate the range, which is the difference between the min and the max, and the standard deviation as part of the standard test result. What it looks for is the range criteria. If the range does not meet a certain number, I believe it's 92% or some other number, I don't really remember. But if the range does not meet, the test instrument would tell you that it did not meet the testing criteria. So the standard does ask for calculating the range and standard deviation, but in order to define whether the test is acceptable or not, it only uses the range criteria and not the standard deviation. So that's just how the standard is laid out.
Okay, thank you, Dinesh. Next question, what is the accuracy of our unit and when do we need to recalibrate it?
The accuracy listed for OT 60 and 80 pp is plus minus 1%, plus minus 2 digits. And remember, it's a voltage meter, and the resolution is 0.1 kilovolts. So again, the accuracy will be plus minus 1%, plus minus 2 digits. The recommended calibration will be every year.
All right, thank you. Okay, and the last question we have for today, what is your opinion about using the sample port on the transformer oil valve?
Well, that small port or that little adapter there to sample oil is mainly for the syringes. So for the amount of oil that is required for the breakdown test is probably too small, and you will take more time than what you want to spend there. And second thing is that remember, you need to flush some oil and kind of clean the valve and all of that path of when the oil is going to come out, so you don't put any sediments that are not really floating in the oil or any water. So you want to clean thoroughly that with flushing oil. So you may be able to use it, but you're going to be spending more time there. And previous to use that, you need to clean or to flush the oil to avoid any external or additional contamination that you are not supposed to have there.
Okay, thank you, Volney. All right, that's all we have time for today. There were a few other questions that we will be getting back to you here in the next couple of weeks. So sorry if we couldn't get to those today. We just want to thank you all for attending. We hope to see you again at our future webinar. The next one will actually be on April 21st, titled Cable Fault Location 202 Advanced Technique. And all right, thank you again. Have a great weekend, and please remember to answer the survey.